Okay, and once the user have been authenticated using process 1, then the process 2 is supposed to kick in. Then the process 2 is supposed to kick in, and it's supposed to read the file. I think that's the example that they give. And what they're saying was that in the time of check, time of use, is that on when they checked for authentication, that's time of check, isn't it? It says, I checked this person. Okay, and time of use, this is when you use the file, right? So then you're using it. In the TOC/TOU attack, you have to have an attacker, okay, redirecting the process in such a way that you now get access to not the non-privileged account, but the privileged account. So, and that's what they said what TOC/TOU attack is. Okay, time of check, time of use attack. So the requirement here is that one needs to be able to redirect. And so the time of check, time of use in this case is, look, process 1 and process 2, there's somehow you can trick the process 2 from not going after. See, process 2 is not the one that's doing the authentication. See, that's the key, isn't it? Okay, it's process 1 that's doing the authentication, and then the process 2 believes, if the process 1 gives a signal that says, look, go access this thing, that it is going to listen to it and go access whatever the file that is supposed to go access. So the flaw here with the TOC/TOU is, you can read it in the book, it's about redirecting to the privileged file. And I've always thought this was also a race condition. That was my thing. So then you look at race condition, and when you're doing the exam, you can always do the process of elimination as well. Okay, and for me, race condition is a little bit more clear as to how you do this thing. Okay, so let me show you what the race condition looks like, and this once again is from the book. Okay, so race condition compared to that thing where you have to do the redirecting and stuff. Here's the race condition. Race conditions, let's say you have two processes, process 1 and process 2. That's supposed to happen in serial. So you have step 1, process 1, and then step 2, process 2. Okay, but the race condition is, what if you can actually bring process 2 before process 1? That's the thing. So, can you switch this thing so that process 2 actually runs before process 1? That's called the race condition. So it's racing, right, to run which one's going to run first. And the example that they gave in the book is, how about authentication and authorization? To access, let's say, a file, right? Because authorization gives you permission to access a file. So if they said that, what if you can actually run P2 first? What that means then is that a person can access something without being authenticated. Okay, so that one is a race condition. So you're changing the order of how the process works, how the process runs. Okay, so that one is easier for me to identify. I'm not exactly sure, I don't have a real, in my head, how you would use a TOC/TOU attack. But let me give you an example. Okay, let me give you an example, and you tell me if this is a TOC/TOU attack or a race condition attack. Okay, so here goes the example. I'm going to scroll down and go to the right. I'm scrolling down to the right. Okay. Okay. So let's say, I don't know, how many of you like Jamba Juice? You like Jamba Juice? Have you had Jamba Juice? Do you have Jamba Juice in your place? We have a whole bunch of Jamba Juices in Hawaii. Oh yeah. Okay. So Lisa, do you have a membership for Jamba Juice? You know, one of those things where you put in your telephone number and you get extra points. You don't. You should. Yeah, you should, because you know they give you great like free drinks and stuff. But anyway, so I have one of those things. Okay, and because they don't give me a card, right? All you do is when you go up to the register, you just type in your phone number. Now that I think about it, if somebody actually knew my phone number, they'll be using my Jamba Juice points. So I'm not going to tell you my phone numbers. But anyway, so that's all that's required. Okay, and what happens is when you type in your phone number, it goes into some kind of network and figures out how many credits you have, like a special savings or dollars worth of credits that you can use against what you're going to spend. So the image is like this. So you have a database. Okay, it's in the cloud somewhere, I don't know. Okay, and in there this says, look, there's a person with that phone number, and it's called Terumi. Okay, wow, the name came out really well. And she has $20 worth of credits, let's say. Okay, it's in a database. And I'm happily in my, Waipahu Jamba Juice, and here I am, and I type in my number. Okay, so when I type in my number and say return, okay, at the cash register, it's going to check, because I'm doing this while I'm ordering too. So it's going to go check to see how much money I have left. Okay, and let's say I'm trying to buy something that's like $10. So I said, hey, I want to buy this thing, which is like $10. Okay, it's going to check to see if I have $10 to spend. This time will check. Okay, I'm checking, right? And it comes back and say, yeah, it's good. It's okay. Good enough. And while this is happening, right, somebody else in some different Jamba Juice, pretending to be me, types in the number. Tries to buy something, a acai bowl or something, that costs like $20. Okay? And in this case, they also check, because you see I haven't spent my $10 yet. So they also check for my $20. Oh. Does this person have enough $20? Yes. Yes, it is. She does have indeed. It's okay. And before me in Hawaii can actually buy this thing, this person elsewhere purchases this thing. Says, I buy it. So this is time of use. Okay? And I'm sure because I use it, right, it is going to update it. Say, okay, update this thing, minus $20. The whole thing is happening. I purchase my $10. And the cash register is not going to go check again because they checked already. It's just that there was a time between the check and this time of use. Okay, so it allows me to buy something that's worth $10. Now when it goes to update, it's going to be not $20, but minus $10. But in the whole process, I was able to get out of this whole system $30. Okay? See that? Okay, do you see what's happening? Okay, so I'm taking advantage of the fact that me in Hawaii spent some time waiting before this purchase was recorded back, right, to the main database. So somebody snuck in right beforehand and purchased it. Okay, so if we were to put this in a different way, from the timing perspective, I'm scrolling up a little bit because I need a little white space. In fact, you know what? Let me scroll down. I think if I scroll to the right, to the left, I probably have some space. Yeah. So here's me in Hawaii, and me someplace else. Whoever it is. Okay. And I said, look, I checked it, and I got an OK on it. Okay. And then before I purchased it, okay, somebody else came between and checked it and then purchased it. You see? This is what happens. So there's a time gap, isn't it? And this is a time gap that was leveraged to purchase something, and it actually went over what I actually had. All right, so if you understand this particular attack, what is this? Is this a race condition, or is this a time of check, time of use example? Which one is it? It could very well be a test question, guys. So what is this, what do you think this is? Is this time of check, time of use attack, or is this a race condition attack? Yeah, Christopher. Time of check, time of use. Anybody else? Everybody else agree with Christopher? You do, huh? Yeah, so let me tell you, that's how I thought it was. I would give this example. Well, actually, I was kind of like way off, because I would say this is a race condition example, okay? And notice how it happens, the time of check and time of use. So I was using both. I was using this example as both time of check, time of use, and race condition. But looking back at the example, this is actually a, unless you could prove me wrong on this, okay? I believe this is a race condition example and not a time of check, time of use example. So let me give you my reasons why. Remember, the time of check, time of use, as far as the definition in CISSP is concerned, is that the second party has to redirect something. There is no redirection happening here, okay? And it's not running on multitasking operating system, right? So because the processes are happening way elsewhere. And the definition of the race condition is that you are changing the order of how things are supposed to work, right? Changing the order. So the normal order of things for this to work is where you have step 1, time of check, and then step 2, right? You receive the information, and step 3, you're supposed to use it, and then step 4, you're supposed to update it. Then only then are you supposed to be able to do the second transaction, which is step 1, check this thing, step 2, get OK on this, step 3, use this thing, and then step 4, update this thing. Notice how the order, if this whole thing had gone in that order, then you wouldn't have been able to use $30. The second time when the terumi elsewhere tries to check and see if there's $20 worth, there's no longer $20 worth. There's only $10 worth of stuff, right? Because it's been updated, okay? But because somebody was able to sneak in the transaction in between another, right? It didn't run in the order they're supposed to, and now you have the race condition problem. So do you see how this is an example more of a race condition, like changing the order of things, rather than somebody redirecting something? You see that? But the terminology, time of check and time of use, is used this way, right? That's what was confusing me when I was initially explaining this. So what do you think now, Christopher? What do you think? And Terry? I still would like to think that this is somehow related to time of check, time of use example. That this is what I'm hoping. So if you could convince me, that would be great. Because that's what I've been telling other customers. Hey, this is time of check, time of use. Yeah, concurrent transactions, right? That's right. Yeah, I know. I know. Yeah, me too. I think this is concurrent. Yeah. But you check it out, okay? Check it out on the, for those of you that's still unclear as to say, which one's which, it's in chapter 7, or it's in domain 7, secure development. And I don't know which page within that, but there's something called TOC, TOU, and race conditions. And read that whole page, and you come back to me, right, maybe after lunch or something, and tell me, because I would definitely like to believe that this is time to check, time of use. It kind of fits, Look, between time of check and time of use, you have this timing thing, and now somebody comes right in and does something, right? So there you go. By the way, how would you fix this? How would you fix this? What can you do to this whole system so that this doesn't happen? Place a hold on transaction during the check pass. That's right. Exactly. That's right. So you make this whole thing into a transaction. See, the problem was this is not a transaction, is it? Right. So if you make it into a whole transaction, you are holding that $20, the balance, steady until one transaction completes. And then you allow for the second transaction to start. Yeah. So making this whole thing into transaction would be it. Terry, were you going to add something? ID check. What would that do? Like a multi-factor? Is that what you're saying? Not anybody can type in my telephone number, verify that the other person trying to use your phone number is yours. That would help, wouldn't it? Yeah, that would. But what if I'm the person that's doing it? See, if I'm the person that wants to get this $30, I know that I only have $20, but I want to buy something at $30. Maybe there's some way that I could subvert it, right? So that would be, multitasking scenario. So if this thing is, the whole thing is online, maybe I could just go ahead and manipulate this thing, so yeah, but hey, multi-layer security, definitely. And the way I explained it, yeah, I could see why you would think that, Terry. Okie dokie. All right, so that was that piece. Let's see this thing. So I'm looking forward to what you find out. And chances are, if you look at some other definition of what time of use, time of check is, time of check, time of use is, it probably does kind of consider that to be time of check, time of use. In fact, I'm just curious, because sometimes CISSP, it takes the body of knowledge, and depending upon which white paper they pull from, they have a different definition. Oh, Wikipedia, I'm sure they have the right answer. See this thing? It says this is one example of a race condition. Okay? Now, but that's not what it says on the CISSP book. This is a great example, okay, of how one's experience can get in the way of passing the exam. So be careful. Be careful. Okay? Because from experientially, I would agree with Christopher. Like I said, Dave, what happened? Well, Dave just left. Oh, okay. But anyway, so you see here, they're saying that this is one example of race condition. So they're saying that time of check, time of use is a race condition. Get that. Okay, so here we go. Getting back. Okay, so any questions on this page? Vulnerabilities for the system? Okay. Vulnerabilities, technology and process integration. Okay, so here we have mainframe trying to integrate with thin client systems. Security is centralized usually, careful control of privileged and non-privileged subjects. You know, when I have customers that are like doing mainframe, has been doing mainframe for a long time, they said, look, we don't have to worry about security because the mainframe actually has security embedded in it. They have a very good security. Okay, so you know, whatever we do, it's within that, you know, secure environment. We don't worry about security. That's what they tell me all the time. And then I ask them, so how come you're attending my class? You know, like application security. Because they say, well, because now we're being asked to open this thing up to like web clients. They're going to be accessing our system, and now we're opening it up, and now the environment is vulnerable now. We don't exactly know how it's going to work, or how security is going to work. That's their concern. Okay, so there you go. Middleware allows for consistent collaborative governance, security, and management. Well, middleware is like, you know, basically APIs, right? So we talked about PaaS, okay, platform as a service. That's the middleware, okay, middleware layer. And you know, you only get to use whatever's under the middleware, like the database server, only in the way that they allow you to you know, access through the API. Okay, they control that. Process integration, embedded systems, pervasive computing in mobile devices. So these are pervasive, or they call it ubiquitous computing. It's everywhere, right? So that's the issue nowadays, because things are crossing the security domain boundaries, right? The trust boundaries all over the place, and we don't know how to integrate these things when they cross. Okay. Those are the issues. Technology and process integration, embedded systems. They say that embedded systems are the advantages is okay. So I'm sorry. It's where it's simple to verify because, you know, it's just right there. It's not that complex. It's embedded systems. But the disadvantage is they're usually, because they have to put in a lot of functionality within this little you know, real estate that you have. It's simple and fewer features, right? They're very purpose-built type of stuff. Okay, so they're simple, and they may not be able to put so many features onto this little embedded systems. So it'll be less than robust security features, perhaps. Difficult to patch up because it's mostly hardware. So that's basically what they're talking about. Okay. Pervasive computing mobile devices. They say that, you know, for these like iPhones and Androids of the world, in general, they're saying that the security is often lowered because of the resource constraint. Once again, you have very limited real estate to, you know, like software and hardware, memory, real estate to put things in there. So it's functionality first normally. You saw the triad of functionality, usability, and security. So that comes into play most of the time. Okay, and there are best practices. There you go, 800-124, 800-53. These are some of the documents that you need to know. Okay, from NIST. All right, let's talk about vulnerabilities. Single point of failure. You see the router, that is a single point of failure. But I would dare say that the application server is also a single point of failure, right? So when we start to think about, you know, how do we make it so that we get rid of single points of failure, it could get pretty obtuse because, for example, well, so the question would be like, how much is enough, right? And so normally if you have something like a router, you know, from the internet, with a firewall into a switch that's connected to C. Okay, well, there's 1, 2, 3, 4, 5, 6, 7, 8 single points of failures. So what you see here is you have, that's a single point of failure, that's a single point of failure, that, 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 that. These are all single points of failures. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so how do you get rid of these things? Well, okay, so here we go. 2 routers, right? ISPs, 2 firewalls, and mesh connection, 2 switches, mesh connection. And so here's the problem, right? You only have this workstation, so this will definitely have to be that way. Then you say, well, how do you stop this server from falling off? Well, you can do a high availability type of stuff, fault tolerant. Oh. Fault tolerance. So you get something like, you know, Stratus computers that has 2 of everything, right? Two power sources, 2 CPUs, 2 network interface cards, 2 of everything. So Stratus is like, you know, highly fault tolerant, very expensive. So places like stock exchanges will use that. Okay, so there you go. So, and I'm just talking about one server. Okay, and you know, you probably want to do something like that too, to make sure that they know about each other. Okay, so that it knows that when one falls off, you know when to switch. So it can get pretty obtuse. See that? And I'm talking about when you have 2 ISPs, you're talking about 2 ISPs. You're not talking about 2 lines from one ISP, because you say, well, what if that ISP goes down? Well, you at least have another ISP that you can get out to the web with. So you know, it's kind of easy to point out and say, that's a single point of failure, but it's really hard to, you know, to have fully redundant, which probably is not even realistic. You know, for management purposes. I'm sure you could do it technologically, but you know, from management perspectives, I think it's going to be a mess. I'm not sure. If you have any opinion about that, just let me know. But here we go. Okay. So single points of failure. So single points of failure number 2. Virtualization increases single points of failure. Oh, how come? Why would doing virtualization increase your threat from single points of failures? Added more surface area and more components that can fail. I'm thinking about that, Terry. I'm thinking, what is it that which point you're pointing out, whether if that's actually single points of failure. Right. Yeah, that's more like what I was thinking, Terry. Yeah, exactly. Yeah, exactly. So within one physical device, you have multiple servers. So if that one thing fails, you got multiple things failing. Unless, of course, you do redundancies. Yeah. So Terry, were you thinking about that, or were you thinking about something else? It sounded like you're talking more about complexity. Yeah, yeah, that's right. And certainly, within that complexity, if single points of failure could also increase as well. Yeah. Exactly. Yeah. So let's keep those two things in mind. Because you're concentrating lots and lots of machines, virtual machines in one physical device, and when that thing fails, boom, a lot of things fail. Yeah, and also the fact that it's complex. So you may not actually know which pieces which pieces are actually the single points of failure pieces, right? Because they are complex. Okay, build in high availability and fault tolerance. Okay, so fault tolerance, the Stratus is an example of fault tolerance. Okay. Common areas to check: data connectivity, network, cluster communication, right? So I'm hoping that the picture that I drew of putting all those lines in there actually covered all these things. Application availability, OS availability, infrastructure, ops, etc. Okay? So those are the points to consider for single points of failure. Okay, client-based vulnerabilities. Right, client-based vulnerabilities. So when the clients fail. And client's weakness. Okay. Mobile stationary system environments, sure, malware and viruses, right? That's basically what they're looking after. The desktop, laptop, thin clients, they are part of what's called the endpoint security. The endpoint security is usually packaged together with data leakage protection, DLP. At least that's the way I sold it. And oh, by the way, both the red company and the yellow company, we both have DLPs too. Endpoint security, yes, it is about protecting the endpoints, but it's actually protecting the endpoint from data leakage. I think that was the main selling point for that. It says, look, where do companies lose data from? Oh, their users. So let's secure them. Okay. So what are some common endpoint security? What are some, if you were to purchase something like endpoint security, what do you get? Any ideas? Antivirus, very good. Anything else? Terry? Host firewall, yeah, good. Anything else? Threat intelligence, how does that work with endpoint security? Dave? Are you saying something like a host-based IDS that feeds into the threat? Oh, okay. What does it do? Does it give information about threat intelligence from the endpoint, or does it give that information to the endpoint to do something with it? I'm just curious. Tracks. I think I probably have to do some reading. Tracks threat and sends them to a threat cloud. So it senses then, right? What's happening, the threat happening at the endpoint, and it sends that information to the intelligence network called the threat cloud. Events that may be a threat, right? So it's almost like IDS? Okay, got it. Not 32 collects data for threat analysis as they update their heuristics. Okay, so not 32 would be the antivirus software? Okay. Yeah, okay. Log and event manager? Right, yeah. How about whole disk encryption? Right, whole disk encryption is part of the endpoint security as well. Sophos does it too? Yeah, sure. And here's a big hint for you. So the PGP, right? What used to be PGP, bought by a yellow company. Okay, so they do that too, right? PGP, not the free version, will do the whole disk encryption and all this protection, the endpoint protection. So people are just going, these vendors, like the vendors that I was in, is going after that market. So that makes sense to couple that with data leakage protection, because they're saying, look, data is leaking out all over the place. Sarbanes-Oxley, especially PCI DSS, requires that you keep an eye on things going out and make sure that the sensitive information is not going out. And from the endpoint, things go out too, right? So, and so if you have one of these protections where people cannot stick in USB or unauthorized USB into their devices, which one is that? Is that a DLP or is it endpoint protection? Yeah, I agree with you. Yeah, that's why we use it in combination. Okay, so there you go. Encrypted, let me see, mobile devices, mobile device management system, encrypted container, like remote wipes and stuff, so you want to control that. And moving forward. Did I miss something? Yeah, server-based vulnerabilities, okay. So the server-based vulnerabilities are then, it is an enticing target, isn't it? Because look, everything supposed to be important is concentrated in one place, a server, okay? So we have to determine how you access that thing, remotely, perhaps to do administrations on it, okay? Determine how configuration management will be done, right? How do you make sure that nobody's making any changes into the baseline configuration that you're looking for? Data flow control. Make sure that people are going in and out in the way that you expect it, analyze data flows, check the controls, right, safeguards, and evaluate least privilege, right? So these are some of the things to do. For server-based vulnerabilities. Databases. Okay, so let's take a look at this, right? So security issues to consider for databases. Inference. Ability to deduce sensitive information. Can somebody give me an example of inference? We did this already, right? Remember? Inference. You infer. No? Nobody has an example? Well, I'm going to wait 3 seconds because we're almost at the top of the hour, actually, to the break. 1001, 1002, 1003. Okay, so the inference attack would be, let's say you want to figure out the salary for all the female executives in your company, and there are only 2. So, and you have an access to a data mining software where you can get statistics. You can't put names in there because there are no names in there, but you can say something like, give me the average, salary for all the executives. Then you say, now let me make that a little bit more clear. All the executives who are female, right? If there are only 2. The value, see, if the sample size is pretty small, you can pretty much, infer what a particular, let's say, a female executive is, getting for salary, because it's only 2. So if you can actually, make that a little bit more, if you can actually do a data mining, says, above the age of 50 or something, then you may be able to kind of hit that person that you want to, right? So that would be inference. Okay, aggregation, combining non-sensitive data to create sensitive data. So we talked about that yesterday, right? Right, California 2, right, Terry? And other states 3 pieces of information. That was very helpful, by the way. Thank you. Yeah, and data mining, querying the data warehouse to discover information. I mean, data mining, the data warehouse is there to be mined. So you can do inference, you can do aggregation, well, mostly inference. Warehousing, some being greater than the individual parts. So that would be the example of the aggregation. Okay. System must be secure. That is ecosystem. That is all the systems that are working together. There are usually disparate systems that are controlled separately that come together to work with each other. So that must be secure. CIA, confidentiality, integrity, and availability still counts. Okay. And think about large-scale parallel data systems like big data. Right. So that would be the security issues to consider. Let me just get a little peek. Okay. I believe at this stage, let's take a 10-minute break, shall we? Because we do have just a little bit more to go. and I think this probably is a good place to break. All right, so see you back in 10 minutes. Thank you.